Hello everyone. This video is going to cover chapter 7 from the textbook. So we'll do chapter 7. So we're going to start with a binary model, which we're going to use again in the following chapters. So the idea is the following. So you're going to discretize time. So let's say here we have t0 is equals to 0. It will be t1, t2, and then at the end you have tn, which has to be the expiration time, okay, the same expiration time we had before, and the length of each interval will be delta t, where delta t is just simply tn minus 1, and obviously tn is equals to n times delta t. In this chapter, we're only going to focus on one step, which will be called a binary tree. But in the following chapters, we're going to do more than one step. So for now, we're going to focus only on one step. We have the following assumptions. We will only have one type of stack, which will be denoted by ST. So remember, ST is the price of the stack at time t. And we only have also one type of bank account, which will be denoted by dt. So therefore Bn will be equals to B0 e to the RTN, or this will be equals to B0 times e to the R and then times n times delta t, because of this part right here. Also, the other assumption is the interest rate, R, it will be continuously. So this is the lazy rate to write continuously. So it will be continuously compounded. So the interest is always continually compounding unless it's stated otherwise. Now this will be the main equation we'll be using. So the value of the stack step n, it will be equals to whatever was the previous value or in the previous step plus whatever was the value in the previous step times some Kc, which is going to be a random variable. So here Kc n is going to take two values. It will be either an if it goes down, or it will go bn if the value goes up. Also the probability that Kcn is equals to an is going to be equals to p, and the probability that Kcn is equals to bn is going to be equals to 1 minus pn, so it should be n. Now this is what we're going to call, well, pn is going to be called the market probability, and you will see that we're going to have more than one type of probability in the class. So therefore this equation you can simplify by factoring s of n minus 1. This will be 1 plus Kcn, and we'll just call this one alpha for now. Okay, so this will be the model. Now this requires the following. The minus 1 has to be less than an, less than bn, and this is to ensure that the price is positive. You should verify that this is the case. This may actually even be a homework problem. You can realize that if this is not satisfied, the value for the price or the value of the stack would be negative, which is technically not possible. Now in this chapter, we're going to focus on a binary tree. Like I mentioned before, this is only one step. Remember that we're going to use a Pn as the market probability. And for the binary tree, we're going to assume that an is equals to a and bn is equals to b, which means the value for each step is going to be the same for a and for b, which could be different. This is actually called the CRR model, and it was invented in 1979, around that time. Okay. So therefore, if we start with the value for Sn minus 1, then the value tomorrow could be Sn with the probability of this, or it could go down to this one, where in this case this will be alpha, which remember alpha is the same thing as Sn minus 1 times 1 plus Bn, or alpha times 1 plus An. And remember that we're going to use to Bn is just going to be B for now, and An will be equals to A. So it's not going to change at each step. Otherwise, if we were doing multiple steps, the value for An here could be different than here and so forth. So this will assume that the value will be the same. All right, so we continue the binomial tree. Remember that we're gonna stick to An is just equals to A, and Bn is equals to A. Now we need the following condition. 1 plus An has to be less than e to the r delta t less than 1 plus Bn. If this is satisfied, then this implies that there will be no arbitrage, which remember is the goal. Now, if this is not satisfied, that means there is arbitrage and somebody can make money for free. So I'll show you an example right now with that. All right, so let's see why if this is not satisfied, you can make money for free. Okay, so suppose then the first part of the inequality doesn't hold. That is, suppose that e to the r delta t is less than or equals to 1 plus an. So therefore that implies if you multiply both sides by Sn minus 1, that this will be less than or equals to Sn minus 1 times 1 plus an. But remember this is equals to Sn. Okay. So let's look to the particular case if n was just equals to 1. So that implies that S0 e to the r delta t has to be less than or equals to S1. So this implies that borrowing money is cheap. So therefore, and you can take advantage of that. For example, let's say that S0 is equals to 100. Let's say that the interest rate is 10%. And let's say that delta t here is equals to 1, or 1 year, just for simplicity. And if we calculate this part, this will be 100 e to the 0.1, which is 110.51. Let's say that the value of S1 is equals to 115.51, which again, I'm just making this number up, but it has to be more than this one. So it could be any number that is less than or equals to this. I mean, bigger or equals to this one. So then what will be the strategy? If this is the case, then that means that at time t equals to 0, you technically can borrow from the bank $100, okay, and then you buy a stock. Then at t equals to 1, you have to pay back 100 e to the 0.1, which is 110.51. But since you bought a stack, now you have a stack, which in 1 year is worth $115. So therefore you automatically made $5 for free. So therefore, if this is the case, this will produce arbitrage. So that's why this has to be strictly less than this. Before we continue, we need to make a few more assumptions. The first one is this: the stock can be bought and sold in unlimited amounts for the existing price, which may not be realistic, but that's the assumption. The second one is the money can be lent and borrowed at a continuously compounded interest rate R. Number 3, there is no charge for holding positive or negative amounts of the stock. And the last one is that there is no taxes or transaction fees, which is actually the case in many places now. There is no transaction fees to buy stocks, but the taxes you can get away from. Okay, and finally, before we go to the next page, remember from last time, okay, we have the payoff functions where this s minus k plus, or f of s was equals to k minus s plus, depending on whether you have a call or you have a put. All right, so we're gonna focus on the one step or single period like I told you already. So let's do an example first, and we will find out that this is not the proper way to do it, and then we'll do it the right way. Okay, so here we have the following. N is 1, which means just one period. Delta t is t, and let's say t is one month. And let's say that the interest rate is 0, and the strike price is 18. Okay. And let's say that we have a call option. So therefore we start with S0, which is 15. Remember that we also call in this one alpha. And we don't actually know the probability, the market probability. So our obvious assumption, which you'll see right now, is not going to be the right assumption. It will be to pick 1/2. Let's say it is half that it will go up, and half that will go down. Now remember, from the call option, the payoff function was equals to st minus k plus. So in our case, this will give you 6, and it will give you 0. Now, if we apply the law of large numbers, or the central limit theorem, which we talked about before, okay, law of large numbers, which requires that we use the expectation. So remember that the expected value of some random variable x is equals to the sum of x times p of x. Now here, with the assumption that this is the market probability, then let's say that C1 will be the price of the call option. Then according to the central limit theorem, or the law of large numbers, the expected value of C1 will be equals to the expected value of the payoff function, which will be S1 minus K plus. Remember that S1 here is what we're calling ST. So then this will be 1/2 times 24 minus 18 plus 1/2 times 12 minus 18 plus, which is the payoff function. Okay, and here remember these are the probabilities. Okay, this one is the market probabilities. So therefore this is going to be equals to 1/2 times 6 plus 1/2 times 0. So this is equals to 3. Now the question is this the actual fair price? And we'll find out right now that that's not the case. So if somebody is willing to pay $3 for the call, this is the strategy we can do at t equals to 0, and then at t equals to 1, because remember we only have 1 month, so this should be t equals to 1 month, or t is equals to that. Okay, so this is the strategy. This is not new, we have done this before. You have this in the last quiz. Okay, so this is what we'll do first. So you can write or sell a call. So let's say write a call, and then at time equals to 0. Okay, this one should go here. Okay, let me write. So first write a call. So right now, then you will get $3 from them. Okay. And then at t equals to 1, you have two choices. Either st will be 12 or st would be 24. Okay. So if you write a call and st is 12, then this value will be 0, and this one will be minus $6 for you. Then you can buy stock. Remember, the stock is the price is $15, so this will be minus 15. If it goes to 12, now you have $12. If it goes to 24, you will have $24. And you borrow $12. So you had to pay 12 because the interest rate is just 0%. So this one always has to be 0, which it is. Notice that this one is also 0, but if the stock goes up, then you can make $6. So clearly that represents a arbitrage opportunity. So therefore, this is not the fair price. All right, so what do we do then? Well, that's what we will see in the next page. All right, so instead, we're going to go this way or use this approach. Here, B0 is going to denote the value of the portfolio times 0. And the portfolio is going to consist of phi and psi, where phi is the amount of the stack. Okay, so you don't have to have a whole number, it could be a fraction. And psi will be the amount of money that you have in the bank, okay, which is getting interest. Now in our model, there's only two things that can happen. The stack can go up or it can go down. So if it goes up, so that's what the 1 means, went up, the first step. Then this will become phi times S0, 1 plus b, and then this will be psi e to the r delta t, okay? Where this part is S1, so that's what will happen at time 1. Now if it goes down, it will be 2b1, and now this will be phi times S0, 1 plus a, plus, again, the money is on the bank. So now for the fair price, the fair price will be the price where B1 should equals to the payoff function of S1. So this is what we want. And then this is called the replicating portfolio, which means you're going to use a combination of the stock and the money so that there is no arbitrage. Okay, so therefore this implies the following. The phi times S0, 1 plus B, plus psi e to the r delta t has to match the payoff when it goes up, which is FV. So this will be the payoff if it goes up. And it should also match the payoff when it goes down. So when it goes down, it should be F of A. So this will be the payoff if it goes down. All right, so therefore, if you do a little bit of algebra, you should check this by yourselves. So for phi will be equals to F of B minus F of A divided by S0 times B minus A. And psi will be equals to e to the minus r delta t times F of V minus F of V minus F of A, B minus A times 1 plus B. Okay, so you should just use a system of equations and you will end up with this formula. So we go back and continue the previous example. Okay, continue the previous example that we did with the low or large numbers and things didn't work out. Remember, there is 0 was equals to 15, k was equals to 18, and it could go up to 24 or down to 12. Okay, so that will be given information. So if that's the case, then we can use that to figure out the values for A and B. So from here we have that 24 has to be equals to 15 times 1 plus B, which means B is equals to 0.6. Okay, remember that you start at 15 and it can go to 24 or down to 12. Or if it went down to 12, then the value for A will be negative 0.2. Again, you should check that that's the case. So therefore here F of B will be 24 minus 18 plus, which we already know this was 6. And F of A will equals to 12 minus 18 plus, which we know it was equals to 0. So then from here, phi, if you plug in the values, it will be 6 minus 0. It will be 15 times 0.6 plus 0.2, because minus and minus is plus. Is equals to 1/2. And then psi will be 1, because the interest rate was 0. It will be 6 minus 6 over 0.8 times 1.6, and this is equal to negative 6. So therefore the fair for price, which means there's no arbitrage, is going to be the following. C0 will be equals to B0, which will be equals to phi is 0 plus psi, and in our case this is equals to 1/2 times 15 minus 6, which is equals to 1.5. Notice that this is very different than the 3 that we got before. Okay, so now the replicating strategy will be the following. At time t equals to 0, or this is what this means, is you borrow $6, and then you use the money okay, plus the premium, which is 1.5 to buy 1/2 of the share, and that will ensure no arbitrage. Now this formula also works for the put. The only difference for the put is the payoff function. Remember, for this one it will be equals to k minus st plus. That's the difference. Okay? So if we use the same information, okay, since you have a different payoff function, that's going to change the value. So now for this one, if it goes up, it will be 0, so that will be the f of b. And if it goes down, this one will be 6, and that will be the f of a. So then if we plug it into the formula, which, remember, this was f of b minus f of a over s0 b minus a. So now this will be 0 minus 6 over 15 times point a, and this is equals to minus 1/2. And then side, this is going to be equals to 1 times 0 plus 6 over point a times 1.6 is equals to 12. So therefore the price of the put is going to be minus 1/2 times 15 plus 12, which will be 4.5. Or you could simply use the put call parity from last chapter. So if we use the put call parity formula, which is the following: d is equals to k e2 minus rt minus s0 plus c0. So in our case, this will be 18 times 1 minus 15 plus 1.5, and you end up again with exactly the same thing, which is 4.5. All right, let's do one more example. Let's say that x0 is 20. Let's say that t is now 6 months, and k is 22, and let's say the interest rate is 12%. Okay. And let's say that the stack tomorrow, and this will be given, it can go either to 27 or 18. Okay. So therefore, from here, you can find that f of b is going to be equals to 5, and f of a is equals to 0. Okay. Why? Well, the strike price is 22, so 27 minus 22 is positive 5. 18 minus 22 is negative, so you go with 0. And you should also check that the value for a is minus 0.10, and the value for b is 0.35. So therefore, if that's the case, then phi will be equals to 5 minus 0 over 20 times 0.35 plus 0.10, and this is equals to 0.55. The value for phi is going to be e to the minus 0.12 times 0.5, because it's 6 months. Then 5 minus 5 over 0.45 times 1 times 1.35, and this turns out to be minus 9.42. Again, you should check all of these values. So therefore, the price of the call, which will be the value of the portfolio times 0, is going to be 0.55 times 20 minus 9.42, which is equals to 1.58. And that's it.